So since we need all 6 trig ratios and eventually angle measures, I need this side length. We're missing this side. So I'll give it a variable, and I'm going to use Pythagorean theorem to figure out the missing side length. So if you were stuck and don't have this opposite side of Q, here, use Pythagorean theorem to get it. We got x squared is 144, so x is 12. So to help me, since we're talking about angle Q, I'm going to label the 12 as opposite, the 9 as adjacent, and the 15 is the hypotenuse. The across from 90 is always hypotenuse, regardless of any of the other locations of the angles. So we've got sine, cosine, tangent, and then the other 3 are the reciprocals. So you have to remember what is the reciprocal of sine. So with sine, that reciprocal is cosecant. So I take this ratio and flip it. Reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Do you have any questions before we do number 2? I've got to get my calculator ready for that. No questions? Okay, so to find the angle, wait, no one said Miss Weiss, you're writing thetas. It's supposed to be Q's. That matters. Can't just make up my own random angle notation here. These should have been Q's. Anybody notice the pattern on how I named this triangle? Quince, Orchard, high school. One year I taught 4 periods of geometry. I got really creative with my polygon names that year. Okay, we got to pick any ratio you want to find the angle. We've got all 6 here. The calculator has sine, cosine, and tangent buttons. So I'm not going to pick the reciprocals when I go to find an angle. I'm going to pick one of my 3 starting functions, sine, cosine, or tangent. Pick your favorite one. In the chat, send me what is your favorite function, sine, cosine, or tangent. No wrong answers. We can pick any one we want. Let me get the other calculator for you. So far, all the votes are for sine. Here's this calculator if you need it. Okay, so for sine, if you're using this Desmos calculator over here, you have to click function and do sine inverse. Go back to main of 12/15 to get the angle out. Whoops, that's not the right spot for that. There we go. To get the angle out, you have to inverse. You can't divide by sine or cosine or tangent. You have to inverse to solve for the angle. If I picked cosine or tangent, it works the same exact way because it's all the same angle. We get 53.1. Okay, so this is 53.1 degrees. To find angle H, I'm going to use the good old theorem from geometry. All the angles in a triangle add up to 180. So we got 180, take away the 90 we already have, take away the 53.1, and we are left with 36.9 degrees for angle H. Other questions? Could you show how to find angle H again? Sure. So I found angle H by saying all the angles add up to 180. So if I take the, excuse me, the total sum 180, take away the 90 we have, take away the 53.1, that leaves 36.9 for the missing angle. Okay, so how did I do Q? So at this calculator, I'm going to do second sine for this sine inverse of the 12/15 using this ratio. You could have picked cosine. You could even pick tangent. All of them give you that same angle value. Okay, so let's talk about our reminders. We've got a short homework today that's due this afternoon or due to by tonight. This is wrong for this week. We have one check-in time tomorrow afternoon. And this weekend, we've got an upcoming quiz. It will be the last grade for the quarter, but we'll talk about that tomorrow when I see you. So for right now, you're writing down day 2 homework due today. Okay, and so some of you already chatted me, you have homework questions. What homework questions do you want me to go over? 11. Okay. So we're given this 41 degrees. I'm missing the opposite side and I have the adjacent side. So if I think of my SOHCAHTOA, tangent is what relates opposite and adjacent. So I'm going to set this up. Tangent of 41 is the missing side over 120. To isolate the variable, we'll multiply by 120. Take out my handy calculator. And the directions say round to the nearest meter. That's a whole number, no decimals. So that's why this is 104 meters. Okay, our new topic today is radian measures. Radians is a unit of measuring an angle. So I don't want you to write anything down here yet. I want to show you this animation about radians. Just like we have, oh, that's already zoomed in, nice. Just like we have different measurements for length, feet, meters, different units that way, we have different measurement units for angles. The first one you are very familiar with is degrees. The new one for us in pre-calculus, and you might have had a little bit in the spring of algebra 2, is radians. So a radian is a ratio dividing the length of the radius with the portion of the circumference called the arc length. So if I take the radius and make it that same length around that part of the circumference, I get 1 radian. I'm going to show you an animation on how that looks. So you take the radius, they wrap it around the outside of the circle, and now this angle measure right here is 1 radian measurement. Here it is again, 1 radian. If we go halfway around the circle, we're going to get 3.14159 radians, which is pi. So it takes 1 radian, 2, 3, a little bit more. So pi radians is 180 degrees. Does anybody want to see these animations again before I go back to the screen share with the flip chart? Okay, so what I want you to write down is radian measurement. That's our topic today. You don't have to write all these bullet points down. What we just saw in the animation is that 180 degrees is pi radians. That's half a circle. So if I go all the way around a circle 360 degrees, it would be 2 pi radians. These are the units we're going to keep coming back to. These are our initial thoughts as far as relating degrees to radians. Okay, so let's use that. We're going to draw these angles. So the first thing we need to talk about actually is the position of an angle. Standard position is we start on the positive, let me write that out, positive x-axis and rotate counterclockwise. So when I have this semicircle here, the initial ray is this blue ray. That's the initial ray. And I'm going to take my other ray and swing it around counterclockwise to get the angle to draw. So this is saying draw the angle of pi over 2. Well, I know halfway around the circle is pi. So that means pi over 2 must be half of this. So this angle here is pi over 2 radians. For pi over 3, we still got this initial ray over here. Halfway around is pi. So I'm going to estimate about 1/3 of pi, because this is like 1/3 of pi, except it's condensed to the 1 fraction, pi over 3. So if I want to split this in thirds, well, that's pretty good. Here would be my terminal ray, where this angle is pi over 3 radians. All of our knowledge, all of this is going to be based off that we know 180 degrees is pi radians. That's what we're going to keep coming back to every time. So Ryan, this is kind of like what we had at the top. This is really the only thing you're missing. Okay, I want you to try these two angles down here, pi over 4 and pi over 6. I'll give you a minute to draw those two. Okay, so pi over 4 is a quarter of pi. So if this is a half, a quarter would be about here. And then pi over 6, that's a sixth of this, so it's half of that third. So if here's the pi over 3, I'll go about there is pi over 6. We're used to degrees, so we're going to convert back and forth from degrees to radians. Eventually, radians is going to be our standard operating procedure. We're going to do everything in radians. So to get comfortable with radians, we're going to convert. We've got degrees, go back to radians. We've got radians, go back to degrees. Everything is still based on that pi radians is 180 degrees. We're going to use that to convert our units. Kind of, you might do this in chemistry where you convert different units, feet per second to inches per minute, something like, we're going to make a proportion. We're going to make a fraction. So every single time, if I set it up as radians over degrees, that'll equal radians over degrees. If I have these equal ratios, these equal proportions, I will be able to convert regardless of what I'm given. The first setup that we know is that pi radians is 180 degrees. So pi radians is 180 degrees. I'm always going to start with that as my initial fraction. I'm going to jump to this 70 degrees per second because there's nothing really to convert here. Like, that's a given. For 70 degrees, I'm missing the radians. I need to find radians given 70 degrees. So if I set up this proportion, radians over degrees is to this many radians that I have to find over this many degrees, I can now solve for the missing variable. Do you have any questions before I solve? Okay, so I'm going to multiply both sides by 70. And we get 70 pi over 180 is my missing radians. I have to reduce the fraction. Everything has to be reduced when it comes to the angle measures. So 70 and 180 is these zeros can simplify. So I'm left with 7 pi over 18. Now let's see, 7 and 18, can that reduce any more? No. So our answer here, our radians is 7 pi over 18. All right, let's try 36 degrees. I'm always going to start. Pi radians is to 180 degrees. I have degrees, that goes on the bottom. I'm missing radians. Solve for the missing part. I'm going to multiply by 36. Then we got to reduce. You can either reduce all in one step, or if you see, sorry, I'm reading the chat question and it froze my brain for a second. I mean, I see your question, give me 1 second. If you can see what to, like if 36 goes into 180 evenly and you know that, you can reduce all the way. If I'm looking at this and I go, they both can divide by 9. Like that's just my first gut instinct that these both divide by 9. Oh, and then 4 and 20, that reduces even more. Okay, so Amina, I just squeezed this in. It's supposed to be 7, it's supposed to look like this, 7 pi over 18. I just didn't have enough. Here, let's go like this, 7 pi over 18. That make it look a little more clear with a less squished pi. And this is the answer to B. Okay, so then for C, this answer is pi over 5. We get pi over 5. Oh, I fit it in. Okay, let's try one more, 210 degrees, and then we'll switch up. We're given radians. So pi radians is to 180 degrees, as my missing amount is to 210.
You want to play something? You want to watch? Do you want to do a puzzle? Do you want to do matching games?
All right, so this, I know these zeros are gonna cancel and divide. So I'm left with 21 and 18 to reduce. And Sophie, you're right, yes. So 21 and 18 can both divide by 3. So if I do that, I'm left with 7 pi over 6. That doesn't reduce anymore, so there's our answer. We got 7 pi all over 6. Okay, so now let's go the other way. If you like this proportion system, it will work regardless if you're given radians or degrees. So like for pi over 2, I'm going to say pi radians is to 180 degrees. Now I'm given radians, I'm missing degrees. Now to solve this, I can multiply both sides by x, but that doesn't eliminate the variable. So what I'm going to do is just cross multiply. It's going to do a lot of the solving in one step. I'm going to go x times pi equals 180 times pi over 2. Then we're going to simplify this. On this side, 180 divides by 2, that's 90. And then I ran out of room here. Divide both sides by pi to isolate my variable, and we are left with x is 90. And that makes sense because pi is 180, so half of pi is 90, half of 180. Now there is a shortcut when you're given radians. If you don't like this cross multiply and solve way, when you're given radians, we can replace pi with 180. We know pi is 180 degrees. So like for 3 pi over 4, pi is 180. So this is 3 times 180 over 4.
What's up? Yeah, Donald Trump is in America.
So I'm going to reduce this. 180 and 4 can simplify. I'm going to reduce by 2 because they're both even. That's 3 times 90 over 2. Oh, wait, 90 and 2 reduce even more. Now I have 3 times 45, 135 degrees.
I got it. That's just 1 year for me.
All right, let's try one more. We got 5 pi over 6. If I do this replacement way, that is 5 times 180 over 6. I like that for radians. It's so much faster than the solving way. The 180 and 6, that can reduce. We get 5 times 30, 150. If you like the proportion way, I'll do the 5 pi over 6 that way real quick before we end here. Pi is to 180 as 5 pi over 6 is to some missing degrees. Cross multiply. Now here's where I can reduce the 180 and the 6. Divide by pi. And we're left with that 5 times 30 again. Okay, this is the homework. It's just practice converting back and forth. Do today, submit that through Canvas. If you have any questions, I'll hang on for a minute. Your next class starts at 9:40. Have a super afternoon.